Hi everyone, we are looking at 314 and 315 part 2. So in part 1 we looked at circles. Now we are going to look at something called roses. So we're going to use the same bit.ly link for the Desmos that we did in part 1. So if you could pull up this Desmos in a different tab, and then that way you are able to follow along with me. So before we get started with these ones, we have a couple questions at the beginning. So we're on page 2 in our notes, and we're going to start with the Desmos. So we have this pulled up, but question 1 has part A and part B. And to get started, we're not looking at circles anymore. So we're going to turn off both of these, cosine and sine, depending on which one was turned up. Go ahead and hit this arrow. We're going to collapse part 1 because now we're looking at part 2. So we're going to open up part 2. And let's start with just cosine. So we'll turn cosine on. And let's just push play on the A slider. We're just going to observe what's happening. So let's pause that. Now let's turn on the N slider. So in our equation, we have an A value in front of cosine, and then we have N that's getting times onto our angle. So if we push play on this, A and N are changing different aspects of our graph. So let's pause that again. And then if we want to do sine, let's turn off cosine and let's see. So I'm going to start with our A value. So as we change our A value, what's happening? And then our N. So based on what we can see, go ahead and pause this video and answer 1A and 1B, and feel free to play around with it on your own as well. All right, so now we're going to look at changing our sliders to match the 4 equations that we have. So we're looking at number 2, and all of these have cosine. So I'm going to turn sine off and turn cosine on. And that first one, our A value is 5, because that's the number in front of cosine, which ours is already set to 5. If you need to change yours, go ahead. And the number inside parentheses next to our variable theta is 3. So I'm going to change this to 3. And so looking at what I have, I'm going to go ahead and sketch this in the notes, and I want you to do the same. And then I'm actually going to do the second one as well, and then I'll give you time to finish the remaining 2. So the second equation, we have r equals -4 times cosine of 5 theta. So our A value is -4. And our N is 5. So I'm going to go back to our slides. So in your notes, you have these 4. We just graphed the first 2. And so I would sketch the best that I could with what I have, making sure that I have a general idea of where the petals are. I want the length of the petals and how many petals. So you can see I did make a little error with the dot here, but that's okay. So I want you to pause the video, do the remaining 2, and sketch those in your notes as well. All right, now that you have done all 4, there are 2 questions on the bottom, question 3 and question 4. Based on the Desmos and what you have, I want you to try to answer these on your own. So how can we tell from the equation how many petals there will be? And then evaluate each of the 4 equations at theta equals 0. So we're plugging 0 in for theta, and we're finding cosine of that number and then multiplying it by that A value. What do you notice? And what does this tell you about where the first petal will be located? Go ahead and answer those on your own, and then when you're ready, we're going to come back to question 5, where we start looking at the graph with sine in it. All right, so all of these have sine, so I wanted you to notice that. So going back to our Desmos, we're going to turn off our cosine equation. We're going to turn on our sine equation. And we are going to do the same thing. So I'm going to let you kind of play around with this, and I'll do the first one. So our A value is positive 5. And our N value, that number inside parentheses, is 3. Excuse me. So I want you to graph all 4 and then sketch them in your notes on page 2. So these are the first 2 that I have, and then underneath we have 2 questions, question 6 and question 7. I want you to try to figure out what similarities and differences do you notice between the equations with cosine versus the equations with sine. So we did cosine first in question number 2, and then we did sine in question number 5, which are the 4 on the screen. See what you come up with, and then try to answer question number 7, and we're going to summarize in our quick notes in the next page. All right, so we are on page 3 in our notes, and we already did small circles on the left. So that part is already filled in. Now we're looking at roses. The difference in the equation for roses is we have an N value in front of theta, where in our circles, the invisible 1 was in front of theta. So to start, we're going to kind of divide this up. So we have something that will be specific to cosine, and we will have something that's specific to sine. And then on the bottom here, it'll be for all roses. So we're going to start with cosine. With cosine, we say that there is polar axis symmetry. So we could fold it on that polar axis, and our roses will line up. So our first petal for cosine is at theta equals 0, and it starts on the x-axis since it's cosine. The difference is if our A value is negative, remember negative will flip to the opposite side, so on like the left side. And then if our A value is positive, it'll start at theta equals 0. Then for sine, we have y-axis symmetry or pi over 2 symmetry. And our first petal for this one is going to be pi divided by 2n. And I want to point out that for circles, we have the same symmetry. When it's cosine, we have polar axis symmetry. When it's sine, we have pi over 2 symmetry, and that's the same thing for roses. So now at the bottom here, we're going to summarize the parts from questions 3 and 4, and then 5 and 6. I'm sorry, 3 and 4 and 6 and 7. So if our N is an odd number, then we have that many petals on the graph. So if our N value is 3, we have 3 petals. If it's 7, we have 7 petals. If N is an even number though, we actually double it to get the number of petals. So if N is 2, we actually have 2 times 2, which is 4 petals. If N is 6, we would have 12 petals. So it is different if N is even or if N is odd. Then to kind of go a little bit further, we might not need this, but the angle between the petals is we would take 2 pi, which is 1 full cycle around our unit circle, and we're dividing it by the number of petals. And that makes sense. They're equally spaced apart, so we take the full circle, 2 pi divided by the number of petals. And then our range is our negative A value up until our A value. So I want you to answer numbers 2 and 3 in the first Check Your Understanding, which is on page 3 in your notes, and that will be the end of this portion.